Computer architecture, first generation, second generation, third generation, zeroth, generation fifth generation, fourth generation, zeroth generation. The zeroth generation of computers refers to the period of computing development before the commercial sale of computers. The zeroth generation includes mechanical computers that used metal gears or electromechanical relays, the Antikythera mechanism, an ancient Greek device, Babbage difference, and analytical engines. Built in the 1820s and 1830s, these engines used binary code, which is still used today, 1890 census tabulator, a mechanical device, Harvard, IBM, Mark Warren. Built between 1940 and 1943, Harvard Mark II and Bell Labs relay computers. Built between 1939 and 1951, these devices used electromechanical relays. Wilhelm Schickard invented the first working calculating machine in 1623. Blaise Pascal built a mechanical calculator in 1642 that used hand-powered gears. Zeroth generation of computers, 1642 to 1946. The invention of mainly mechanical computers started the zeroth generation of computers. In 1642, a French mathematician, Blaise Pascal, invented the first automatic mechanical computer named Pascaline. He made this calculating device for his father to calculate taxes. First generation. The first generation of computers were developed between 1946 and 1959 and were characterized by the following features. Vacuum tubes. The main electronic component was the vacuum tube, which was used for memory and circuitry. Size. They were very large and often took up an entire room. Speed. They were very slow. Power consumption. They consumed a lot of electricity and generated a lot of heat. Input-output devices. They used punched cards, paper tape, and magnetic tape. Programming language. They used machine language, which is binary code. Operating system. They mainly used the batch processing operating system. Cost. They were very expensive and only large organizations could afford them. Reliability. They were very unreliable and would frequently shut down. Some examples of first-generation computers include the ENIAC, UNIVAC 1, IBM 650, and IBM 701. First-generation computers. The period of first generation was from 1946 to 1959. The computers of first generation used vacuum tubes as the basic components for memory and circuitry for CPU, Central Processing Unit. These tubes, like electric bulbs, produced a lot of heat, and the installations used to fuse frequently. Second generation. The second generation of computers, also known as transistor computers, were smaller, faster, and more reliable than the first generation of computers. Transistors. Second-generation computers used transistors instead of vacuum tubes, which were bulkier, generated more heat, and were less reliable. Size. Second-generation computers were smaller and more compact than first-generation computers. Speed. Second-generation computers were significantly faster than first-generation computers, with data processing times reduced from milliseconds to microseconds. Energy efficiency. Second-generation computers were more energy efficient than first-generation computers. Memory. Second-generation computers used magnetic core memory and magnetic storage disks. Programming languages. Second-generation computers used high-level programming languages like Fortran and COBOL. Input-output devices. Second-generation computers used punched cards and magnetic tape. Examples of second-generation computers include the IBM 1401, IBM 7090 and 7094, and UNIVAC 1107. Second-generation computers remained the mainstream design until the late 1960s, when integrated circuits started appearing and led to the third generation of computers. A second-generation computer, through the late 1950s and 1960s, featured circuit boards filled with individual transistors and magnetic core memory. These machines remained the mainstream design into the late 1960s, when integrated circuits started appearing and led to the third-generation computer. Third generation. The third generation of computers were developed between 1965 and 1971. They were smaller, faster, and more efficient than the previous generations, and were the first computers to resemble modern computer systems. Integrated circuits. The main electronic component was the integrated circuit IC, which could contain thousands of circuit elements. Jack Kilby is credited with inventing the IC. Size. Third-generation computers were smaller and cheaper than second-generation computers. Speed. Third-generation computers were faster than previous generations and could calculate data in nanoseconds. Memory. Third-generation computers used large magnetic core, magnetic tape, and disk. Programming languages. Third-generation computers used high-level languages like Fortran, BASIC, Pascal, COBOL, and C. Input and output devices. Third-generation computers used monitors, keyboards, magnetic tape, and printers. Energy production. Third-generation computers produced less heat and energy than previous generations. Examples of third-generation computers include IBM 360, IBM 370, PDP-11, and UNIVA C1108. Third-generation computers used integrated circuits in place of transistors. With the use of integrated circuits, these computers became reliable, generated less heat, were small in size, fast, very less maintenance, and were inexpensive. It was developed in 1958 by Robert Noyce and Jack Kilby. Fourth generation. The fourth generation of computers were developed between 1971 and 1980 and were characterized by the following features. Microprocessors. Fourth generation computers used very large-scale integrated VLSI circuits, also known as microprocessors, which were made up of thousands of transistors on a single chip. Speed. Fourth generation computers were faster, more reliable, and more accurate than previous generations. Size. Fourth generation computers were smaller and more portable than previous generations. Power consumption. Fourth generation computers required less electricity to run than previous generations. Operating systems. Fourth generation computers operated well with graphical user interface-based operating systems. Programming languages. Fourth generation computers used high-level programming languages like C, C++, C++, and DBase. Memory. Fourth generation computers used semiconductor memory like RAM, random access memory, and ROM, read-only memory. Input-output devices. Fourth generation computers used keyboards, pointing devices, optical scanning, monitors, and printers. Fourth generation. The first personal computer, PC, was developed during the fourth generation of computers. Intel was the first company to develop a microprocessor. The fourth generation lasted from 1971 to 1980. It resulted in the invention of the microprocessor. Semiconductor memories have taken the place of magnetic core memory. During this time, computer operating institutions were designed. Users benefited from the usage of graphic user interface technologies. Fifth generation. The fifth generation of computers is a group of computers that began to be developed in the 1980s and were primarily used in the 1990s. These computers were based on logic programming and massively parallel computing. Some of their key characteristics include artificial intelligence. Fifth generation computers use artificial intelligence to reason and make judgments. Ultra-large scale integration, ULSI. ULSI technology uses millions of transistors on a single microchip. Parallel processing. Fifth generation computers use two or more microprocessors to run tasks simultaneously. Natural language understanding. Fifth generation computers can understand human language. Power consumption. Fifth generation computers consume less power and generate less heat. Speed. Fifth generation computers are faster, more accurate, and more reliable than fourth generation computers. Size. Fifth generation computers are small and portable, but have a large storage capacity. Input-output devices. Fifth generation computers use keyboards, monitors, mice, touchscreens, pens, speech input, and more. Examples of fifth-generation computers include desktops, laptops, tablets, and smartphones. The fifth-generation computer systems project was a 10-year initiative launched in Japan in 1982. The project contributed greatly to the development of concurrent logic programming. The end. Thank you for watching.